For the first time ever, a commercial space station company has secured both a launch contract for its space station and a planned mission involving human visitors. In this video, we will explore the new team project between VAST and SpaceX called Haven 1, as well as take a sneak peek into the new SpaceX Raptor engine version 3. These new Raptor 3s could open the door to even larger launch vehicles and payload missions from the company. But how exactly will SpaceX use all this extra engine power? And how will the Haven 1 be any different from the International Space Station? VAST, an innovative startup specializing in artificial gravity space stations, has declared its ambitious plan to launch the world's first commercial space station into orbit. This monumental venture will be made possible through its partnership with SpaceX, which will be responsible for not only the station's initial launch, but also transporting the inaugural human occupants using their state-of-the-art Dragon crew capsule. Jed McCaleb, the senior CEO of VAST, shared his excitement for this groundbreaking endeavor. He eagerly announced the launch of Haven 1, the world's pioneer commercial space station, along with its initial crew dubbed VAST 1. Expressing his appreciation towards SpaceX, McCaleb regarded this partnership as the thrilling commencement of VAST's grand vision to launch even larger artificial gravity space stations into Earth's orbit and beyond. Supporting the missions, SpaceX will supply various services such as launch assistance, mission simulations, and life support systems. VAST has also sought the counsel of numerous SpaceX veterans who will act as technical advisors. Tom Ocanero, Senior Vice President of Commercial Business at SpaceX, perceives the launch of a commercial rocket carrying commercial astronauts to a commercial space station as the future of low Earth orbit. With their collaboration with VAST, they're steadily making this vision a reality. Last year, VAST revealed its bold ambition to construct a 100-meter-long modular artificial space station equipped with artificial gravity generated by rotational velocity. The first step towards realizing this goal is the launch of Haven 1. Initially, Haven 1 will operate independently, but in the future, it will merge with other modules launched subsequently to form a larger VAST station. Designed to fit atop a SpaceX Falcon 9 rocket, Haven 1 is compact enough for launch, yet spacious enough to host 4 crew members comfortably. This advanced station, slightly over twice the height of SpaceX's human-rated spacecraft, includes a docking hatch compatible with the Crew Dragon. In its early stage, VAST Station's primary purpose will be to serve as an extended destination for Dragon flights. This will allow 4 passengers to enjoy a somewhat larger living space and engage in activities such as science, research, and in-space manufacturing for up to 30 days in orbit. The station also boasts continuous power supply, 24/7 Wi-Fi connectivity, and essential consumables throughout the stay. VAST 1, the pioneering mission intended to host the first quarter of human occupants on the space station, is now open for reservations. VAST warmly welcomes not just space agencies and their professional astronauts, but also private individuals with aspirations for scientific or philanthropic contributions in space. The selection process for the VAST 1 crew is currently in motion, with the final team to be unveiled at a future date. Once the crew is established, SpaceX will step in to offer comprehensive training, utilizing their Falcon 9 and Dragon spacecraft. The training will cover a range of essential skills from emergency readiness to spacesuit acclimation, along with entering and exiting the spacecraft. Furthermore, it will involve both partial and full mission simulations, including crucial procedures like docking and undocking to ensure a safe return to Earth. The partnership between VAST and SpaceX doesn't stop there. VAST holds an option for a follow-up mission, aptly named VAST 2. If everything goes according to plan, this second voyage could take to the skies and into space as soon as 2026. As the retirement of the International Space Station looms on the horizon in 2030, numerous companies are vigorously fundraising to pioneer private living quarters in low Earth orbit. Among these companies is Blue Origin, with an ambitious goal to have its orbital reef station operational by 2027. Simultaneously, Voyager, Lockheed Martin, and NanoRacks have joined forces to create Starlab. This station, projected to be ready within a similar time frame, will house a 4-astronaut crew and will significantly downsize from the ISS, offering about a third of its pressurized space for human occupancy. This smaller design enables the consortium to aim for a single launch to send Starlab into orbit, similar to Haven 1, deviating from the multi-launch modular approach adopted by the ISS and the Chinese space station. Starlab's central feature will be an inflatable habitat module, crafted by Lockheed, accompanied by a docking node for incoming cargo and crew transfer spacecraft. It will also incorporate a robotic arm similar to the one on the space station, aiding in external cargo and payload handling. However, the race to establish private space habitats is far from a two-horse affair. Axiom Space is also mounting a significant challenge to VAST, setting its sights on launching the first segment of its planned orbital platform in late 2025. With a substantial $130 million raised, Axiom Space has demonstrated that it can inspire investor confidence in its ambitious vision. Selected by NASA to contribute privately developed modules to the ISS, Axiom Space envisions a progression from augmenting the current station to creating their own fully private orbital platforms, intended for research, space tourism, and more. This vision gained further credibility recently on May 21, 2023, when Axiom Space facilitated Axiom Mission 2, which saw 4 astronauts ascend to the ISS aboard a SpaceX Dragon spacecraft and Falcon 9 rocket. With several competitors striving to make their mark in the realm of commercial space habitation, one might wonder, what sets VAST apart from its formidable contenders? Despite the fierce competition in the realm of commercial space habitation, VAST distinguishes itself through a well-articulated and unique vision for its space station, separating it from both the ISS and other contenders. Once Haven 1 is successfully deployed and operational, VAST has outlined plans to send up its first Starship-class space station module. Described as a 7-meter diameter vehicle, this module offers unmatched potential for diverse applications, such as research and space tourism. By 2030, VAST intends to take a quantum leap with its future missions. First on the list will be the creation of 100-meter-long spinning stick space stations that emulate various gravitational environments. These habitats will mimic the gravities of Earth, Mars, the Moon, and asteroids, offering a unique experience for their occupants. The final piece in VAST's grand vision is the launch of proliferated station fleets in the 2040s. These specialized stations, with artificial gravity and zero-gravity environments, will be optimally designed to support human physiology and psychology. The aggressive timeline set by VAST for the inauguration of the world's first private space station is ambitious and notably ahead of its competitors. Under Jed McCaleb's leadership, VAST stands on the verge of making history. If all proceeds as planned, by 2025, VAST will earn the accolade of being the first commercial rocket company to construct its own space station. However, as the space station begins to materialize, the escalated payload and frequency of missions will undoubtedly pose a colossal challenge for SpaceX. This brings us to a crucial question. How will SpaceX tackle the intensified demands of delivering heavy equipment to orbit? Fortunately, SpaceX has just put its latest version of the Raptor engine, the V3, through rigorous testing. This iteration brings with it a substantial performance enhancement, which could be crucial in managing the escalating demands of heavier payloads and frequent launches, among other benefits. On April 20th, SpaceX engineers had a golden opportunity to gather crucial data on the Raptor engine and the stainless steel rocket ship during its first fully integrated test flight at SpaceX's Starbase facility in Boca Chica Beach, Texas. Although the vehicle did not reach orbit, the 4-minute flight reaching nearly 40 kilometers above Earth provided invaluable insight into necessary improvements for achieving orbital flight. The Starship prototype was fitted with the Raptor V2 engine, lauded by SpaceX for its increased power and reduced parts count, resulting in a lighter engine compared to its predecessor, the V1. With less visible plumbing and wiring, the V2 maintained similar dimensions to the V1, including the nozzle exit diameter, but managed to shave off weight, weighing in at 1,600 kilograms compared to the V1's 2,000 kilograms. Additionally, the V2 displayed an impressive thrust, generating around 230 tons compared to V1's 185 tons. This week brought more exciting news as the third iteration of the Raptor engine, the V3, set a new record for thrust. Raptor V3 just achieved 350 bar chamber pressure. Congrats to the SpaceX propulsion team, announced SpaceX founder Elon Musk via Twitter. He further added, Starship Super Heavy booster has 33 Raptors, so total thrust of 8,877 tons, or 19.5 million pounds. This record-breaking thrust, if proven reliable in future tests, will crown the Starship as the most powerful rocket in history. As VAST and SpaceX team up, We're getting close to the day when space isn't just for astronauts, but for anyone with a dream of reaching the stars. With the launch of Haven 1 and the missions that follow, we're not just blasting rockets into space. We're changing the way we think about our place in the universe.